All right, thank you. As you just said, this talk is called Package Managers and Puppet. And since I know a bunch of people in the back want to be able to see what's going on, I already put the slides up on my company's blog. You can get the slides at blog.packagebot.io. You can follow along if you're in the back. There's going to be a bunch of code and stuff like that that will probably take up the entire screen, and you might not be able to see if there's like people in front of you or whatever. So just to get started, my name's Joe, and I think the following list of things are cool. I think computer programs are cool. Reproducible builds and reproducible infrastructure is pretty cool. I like automation as well. Configuration management is also pretty dope. And I also like Todd Digg. When I was giving this talk to a friend of mine in San Francisco, he was like, "Oh, is Todd Digg like some kind of new tool or something?" And no, Todd Digg is actually food. So if you guys, if you've never had Persian food before, you should try it. It's a really good rice dish. And so just a quick slide about where I work and what I do, and then we can get into stuff. So I work on a website called packagebot.io, and what Packagebot does is it makes it easy to upload, download, store, and delete software packages. And it's really dope, so you should use it. Okay, so this talk is about packages. Packages are really, really important. They're sort of a really fundamental tenet to building computer systems. And sort of like the really mischievous thing about packages is that everyone interacts with them to get their computer set up, and they think that packages are really straightforward, I know how they work, and I can install them, what else do I need to know, right? But it turns out that there's a lot of really, really important nuances to packages and package repositories and everything around that, especially if you care about automation and testing and stuff. So I'm going to start by just asking, by just going through why this is important. So packages are sort of central to maintaining, building, and testing infrastructure in the same way. Packages are also primitive in Puppet, right? There's the actual package resource type you can use to install packages or remove packages and mess with them. Understanding where packages come from and how to store them properly is sort of a requirement for infrastructure of any size. We'll sort of see why that's the case as I go through why this stuff is important. And sort of the last point about why this is important, so just because like I said before, packages and packaging are extremely tricky, and there's a couple options specifically around GPG and security and stuff like that I'm going to talk about later that people really seem to get wrong more often than they get right. So hopefully the information in the software will sort of clear up a lot of misconceptions about how GPG works, especially as it relates to packaging. So the talk's going to start with just talking about what is a package, what comprises it, what is a package manager, what are the pieces involved in package management. And I'm going to talk I'm going to take a little tangent about this whole pattern that a lot of you may have seen on the internet and sort of public manifest, this pattern of doing a configure, make, install inside of a Puppet manifest. And I'm going to talk about why people do that and why doing that is a bad idea and what you should do instead. And I'm going to talk about different open source tools for package repositories and sort of how to manage all these things together with Puppet. So sort of just the general overview of where hopefully this talk's going to go. Okay, so start with what is a package? A package generally consists of metadata, and metadata we usually describe with a version, architecture, dependencies, build time, size, so on. And then the package will also generally consist of the files that actually need to be written to the file system, right? So if you're installing Nginx or Redis or Ruby or whatever, those actual binaries will be included in the package as well. And there's lots of different package types. I'm just going to very briefly go over two really common package types and sort of what the actual inside of that file format looks like. So here's sort of a really common package type, right? RPM package. Anyone who uses CentOS, RHEL. I honestly thought that's how you said it. I don't know. So RPM packages are used on CentOS, RHEL, Scientific Linux, Fedora. And they typically have a .rpm file extension, and they can be inspected and installed and removed with the RPM binary. RPM packages are actually really interesting because they're actually just a header structure that's made up of binary data on top of a CPIO archive. So if you really wanted to extract an RPM without installing it, you could actually use a bunch of command line tools to do that. There's actually a program called RPM2CPIO you can use, or if you don't have that for some reason, if you're really good with reading binary data, you can actually just use DD and then pipe the output of DD and CPIO to extract it if you need to. You can read more about, like, there's a lot of information you can run with RPM. You can read more about them on the man page. Like, you can query the files that are in a package. You can find out what the dependencies are. You can find out what the architecture is. You can find out what source package this binary package came from. There's just a lot of stuff you can query. And if you check out the man page, you can get more information about that. Another common package type is the Debian package. That package, they're used on Ubuntu, Debian, Knoppix, and sort of like all of the Ubuntu or Debian derivative distributions. They have a .dev file extension usually, unless you're using one of the embedded Debian forks, which usually has like a .udev file extension. And those packages can be inspected, installed, and removed, all with a binary called dpackage. So dev packages are actually AR archives, and they contain a version file. And the version file is actually not the version of the package, the version of the package format. There's also a data tarball, and that contains the actual files that are going to get written into the file system. And there's also a control tarball, and the control tarball actually contains the metadata that describes the package in a plain text format. So if you actually wanted to know like really in-depth information about a Debian package, but you didn't have dpackage, which are on whatever, like a Red Hat machine or something, you can actually just use command line tools to extract the Debian package and read all the information out of it. You can read the pre-install scripts, the post-install scripts, and just all the metadata about it by just extracting the tarball that's inside of the AR archives. You can actually GPG sign Debian packages, but it turns out that GPG signatures for Debian packages are actually never verified at all. And so I see like a lot of people who will offer packages up online, like a Debian package, and will say, hey, like this is my Debian package, this is my GPG key. Like that's dope, but the thing is that verifying GPG signatures in Debian packages is actually disabled via a configure flag in Etsy. And there is a GPG signature that's verified, but it's not on the package itself. I'm going to talk about like later. There's actually sort of two sets of GPG signatures around packages and repositories for both Debian packages and RPMs. And this is sort of like a big source of a lot of confusion about like how GPG works and like what gets signed and what gets verified. So I'm going to go into more detail on that when I get to like the repository section of the stuff. But if you want to find out more information just about like the commands you can run a dpackage, just check the command page. There's a dpackage-c, which is really useful, and that allows you to examine the contents of the Debian package without actually extracting it. So if you want to know a particular file inside of the Debian package, you can just use this binary to see what's inside of it. There's lots more package types, right? Like there's Ruby gems, Python eggs, NPM packages, there's Java maybe stuff. And a lot of packaging systems also have this concept of a source package. Specifically like Debian and RPM packages, they have binary packages and they have source packages. So what's the source package and why does anyone care? Well, the source package generally consists, again, of metadata, like version, the architectures you can compile the source on, build dependencies, stuff like that, and the actual source files, like the C source, C++ source, Python scripts, whatever. And the key thing about them is that, key thing about source packages is that you can actually rebuild a binary package from a source package. And so the reason why that's super dope is because like if you're debugging some segfault on a machine that you have and you want to see the exact source code that was used to generate the binary that segfault in, you can go and install that source package and then examine the source exactly in the state that it was in when it was built and put into an RPM, right? So if there was like a bunch of patches applied by Debian or Red Hat or whatever prior to the binary being output, you can actually just install the source package that will prepare the source and apply all the patches that were applied by the actual distributor. And then you can examine the source and actually debug it if the problem happens, right? And so this is sort of one of the main reasons, like anytime I have like a segfault with like Ruby or something in production, like I can just go and install the source package and I can actually read the source and figure out what's going on. So I don't know, it's super useful if you actually have source packages for all of your binary packages. So installing a package with Puppet is super basic. Probably like anyone who's used Puppet has seen something like this, right? You just give the name of a package and then ensure the latest version. That will install the latest version of that package on your system. In particular, this package, PyGPG, is a really, really important package for Red Hat-based systems, and it's used with GPG signature verification. And I'm going to talk about this package a little bit later when we get more into like the GPG verification aspects of packages and package repositories. But anyway, you can, so this is how you install a package. If you want to ensure that you have the latest version installed, you can just do that. If you want to install a specific version, right, like you can just pass the version string, as you can just set ensure to the version string, and then that'll attempt to install a particular version of the package, right? One thing you have to watch out for, though, obviously, is that the official distributions will, from time to time, remove a package from their official repositories. So if you had installed, like, I don't know, Percona or, I don't know, like Redis or something from, the official Debian repositories, and you have a specific version hard-coded into your public manifest, if that version goes away, like if the Debian guys go in there and they're like, okay, we just only need to remove it for whatever reason, they remove it, then, if you try to spin up new infrastructure, your spin-up process could break if you don't have another copy of that package cached somewhere. So that's something you have to watch out for, like around packaging and distribution. The distributions sort of have their own rules about what they do and how they do it and when they do it and everything. Okay, so just to summarize, like the basic stuff we just went over, right? Packages are a collection of files with metadata. The metadata actually has information like the architecture of the machine or the architecture that the source can be built on, the version information, dependency information, and just a lot more stuff. And the key thing about packages, right, is that installation is really, really easy if you don't have any dependencies, right? So if you don't have any dependencies, you can just like really, really easily install a package and not worry about it, right? But if you have dependencies, things can get a little bit more complicated, especially if you're trying to roll your own packages or trying to install something you found out on the internet somewhere. So installing a single package is as easy as if you're using a command line, just dpackage-i filename.deb or rpm-ibh filename.rpm. Instead of doing those, of course, you should just use Puppet instead to install your packages. But the question remains, right? Like you want to install some program, and like that program needs a bunch of other programs. So what happens? Right, so for example, you want to install Nginx, right? Nginx depends on libsSL and depends on zlib, and libsSL and zlib, like they all depend on other things, and those things depend on other things, and those things depend on other things, forever pretty much, until your computer runs out of disk space. So that's just, it's just a lot of packages, right? Like you need to go and download every single one of those one by one and arrange them in the same spot and install every single one of them to actually install complex application, right? And so the solution to this problem is to use a package manager, right? So, what is a package manager? Well, a package manager is just a collection of software that allows you to install, upgrade, or remove packages. You can also query package information from the local system or in remote repositories. So you can ask the question, like, if you have a file on your file system and you want to know, hey, like, where did this like random file, this random configuration file, where did it come from? You can actually query your remote repository or your local cache and say, hey, what package provided this file? And you can see, oh, okay, this package specifically, this file specifically was written to the file system when I installed, Ruby 2.1.0 or whatever. And some package management tools include like more advanced features like mirroring or caching and other stuff like that to help prevent against the case where you depend on a specific version and then the distributions remove that version and then now like all your instructions broken. So like there's tools and stuff built to help people deal with these sorts of situations. I'm going to quickly go over like sort of the two common package managers and just some information about them. So Yum is a really popular package manager. Stands for Yellow Dog Update or Modify. I have no idea why. I think it's just, it was like the original version was called Yellow something else, and I don't know, whatever. It's common on RHEL, CentOS, and Fedora. It's used for installing, removing, configuring, and querying RPM packages and their dependencies. Another common package manager is apt. Apt stands for the Advanced Packaging Tool. It's common on Debian, Ubuntu, Knoppix. It's used for, again, just installing, removing, configuring, and querying Debian packages and dependencies. So that's pretty dope, and you might be wondering, like, okay, if I go and I install a package using, my Puppet manifest, like we saw on one of the earlier slides, where you just say, package, and then the package name, like, what happens, right? Like, how does Puppet know what to do or whatever? Well, it turns out that when you install packages with Puppet, Puppet will automatically detect which package manager you should use, and so that means that you don't actually need to worry about what command to run or like what flags to pass or anything. Like Puppet will just take care of all that for you. So you should always make sure use Puppet or use some kind of automation when installing packages, so you don't have to actually deal with the individual differences, at spin-up time for your nodes. So just to summarize, our package managers help you install software and the associated dependencies. You can easily remove, upgrade, and query packages, and Puppet will automatically detect the system's package manager when you install a package and use the appropriate commands to install the machine. Okay, so I'm going to take a short tangent that's going to tie back into the whole idea of why packaging is important. And I'm going to start by just presenting a problem that anyone who's been managing infrastructure for a while has probably run into a problem like this. So you run Ubuntu 10.04 LTS, right, or whatever, a really old version of 10.5, something like that, right? And you want to install Redis because you're on this web app and it uses Redis, and Redis is cool. So Ubuntu 10.04 comes with Redis Server 1.2.0. Turns out that that's actually really, really old. The current version is 2.8.19. And so now what? Right, you need to install a version of Redis, but there is no actual Redis. That's the version that you need. So what do you do? Well, there's a common solution that I've seen on the internet that a lot of people do. It's not great, but it's a solution. A common solution to this sort of problem is just build Redis or Ruby or MySQL or whatever from source directly in your Puppet manifest. And here's an example that I found online. And I'm not trying to rag on whoever wrote this. I'm not trying to hate on or anything. Right? This is a common solution to this problem. I'm going to talk about in a bit why this is not the best way to do it. But this is a sort of and this is probably hard to read. So if you just go to the blog link, just blog.packcon.io, you can follow along on your laptop. But this Puppet manifest is literally just building Redis, just in the manifest. And it's gonna, if you look down here, you can kind of see there's this unless thing right here, which is gonna try to only build Redis if it's not there already, or if it's not the right version or whatever. And there's kind of this thing we just build it, only build it one time. This whole thing is idempotent, this is not gonna build it again, right? And this is the common solution, right? I've seen this in a lot of just people have a gist, oh, how did you get Ruby 2. Whatever on your server? And someone's oh, I use this gist, and you go to the gist, and it's basically this, but just compiling Ruby in the manifest, right? And so why do people do this? Well, people do this because it's really easy, right? It follows a known pattern, right? Just configure, make install, and everyone goes home. It works. And you're using Puppet, so it's reproducible, right? You can add a bunch of cases to it to try to make it idempotent, and hey, right, it's all automated, so who cares, right? But there's a bunch of caveats that are actually really important to consider when using this pattern, right? What happens if you need to, completely remove Redis, right? None of those files are being tracked when you do the make install. They're just getting written all over the file system. So if you need to delete it, what do you do? If you need to install a security update, right, that only updates a specific component of the system, or updates a few components of the system, but not all of them, or whatever, right? How do you deal with that if you're just running make install? If you want to install a new version, what happens? Do you uninstall the last one? Do you install the new one? What gets overwritten? What doesn't get overwritten? Does everything get removed properly? What if you want to install the same exact binary on all 200 of your machines? If you're using the make install method, you're kind of out of luck for a lot of reasons, right? Not all make files have uninstall targets. So I write a lot of software, and I'll do a bunch of development in a VM, and I'll try someone's tool to do something, and I'll run make install, and I'll be okay, cool, I don't want this anymore. And I go to run make uninstall, and make just says, oh, there's no uninstall target. Cool, well, that's dope. Now there's some files I can't get rid of, so I don't even know where they went or anything, right? And so if you're running make install in Puppet manifest, right, and it just so happens that particular software project doesn't have an uninstall target. So I'm pretty sure Redis does have an uninstall target, but a lot of things don't. And if you don't have one, then you're kind of out of luck, right? You're just going to leave artifacts all over the file system, and having artifacts all over the file system makes it really, 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 really hard to debug problems later, because something explodes or something seg faults, something runs out of memory or whatever, and you have no idea if the thing is actually linking against the other libraries that you think it is, if it's importing stale dependencies from a previous make install you ran, or what's going on. And even worse, if the build process for the thing you're running, make install on changes version to version, it would be extremely painful to roll back, right? Imagine a project switches from using auto tools to using scons or CMake or whatever. Now you have to sort of figure out how to change the build process in your public manifest without like breaking any of the other infrastructure stuff you added in the meantime. And it's just like a huge, huge pain, right? Not to mention that rebuilding the same source code does not necessarily mean you get the same byte for byte binary. This is actually an active area of research in the future that's being worked on for, I believe, I forget what the next release of Fedora is, but like I remember reading a couple people talking about how they're working on this idea of compiling the same source, giving you the same byte for byte binary on your system. And this is actually like a really, really, really difficult problem for a lot of reasons. But anyway, if the binaries aren't identical, you can actually end up with bugs in some of the compiled binaries, but not others. And that's bad because that's really, really painful to debug. And it's also really painful just to recreate a build inside of Puppet, right? Like you need to actually like apply this manifest and like wait forever for the thing to build, and then like figure out a way of testing it, and just iterating is just like really, really painful. And if you use Beaker or Kitchen CI or whatever to test your infrastructure, it makes writing tests really, really, really painful. So
sorry, kind of new. So if you're building from source, why would you not get the same byte for byte binary?
Sorry.
Timestamps. Timestamps in the binary.
Yeah, so there's timestamps. There's also just natural package drift. So like, you might have like whatever 100 nodes, and you might have run like apt-get upgrade or yum update at different times, meaning that you might get different versions of GCC or different dependent libraries on machine depending on when you do the update. And so when you actually go and you try to compile that source using those tools, you might not get the same byte for byte binary as a result of it. Does that answer the question? Cool. So anyway, the solution for like all this pain is to make a package. And you can, if you make a package, you can install the same binary on every machine. When the package is removed, all the install files are also removed. And versioning of the build process is built in with most tools, right? So you can actually keep your public manifest just about config management, and you can put like all the build related stuff into like the package configuration itself. And in that sense, right, like your build steps are factored out into the package, right? So if you want to iterate on the package, you can just iterate on the package. If you want to iterate on your public and your configs and stuff, you can iterate on those, and like everything is sort of separated out. It makes it easy to decouple your systems and like work on things in parallel. So your new manifest becomes similar to the manifest we looked at in the beginning, which is just package ready, ensure latest, and then it's installed. And your package, your build steps get encapsulated in the package itself, as I just mentioned. It makes iterating more straightforward, and you don't need to apply potentially a lot of manifests to a machine every time you do a build, right? So if you're building like Ruby or whatever, and it takes a really long time to compile, you don't need to worry about applying like all these manifests to a machine just to rebuild Ruby so you can test something out. Like you can just install the package in a VM and mess around with it and do whatever, right? So, okay, like, that's cool, right? Like, maybe, hopefully you're sold on, like, why packaging is important, and you might ask, okay, well, like, how do I actually make a package? I'm just gonna name the tools, I'm not gonna go into depth onto, like, exactly how you use them. It would just take way too long, and I just don't have enough time to go into, like, how to actually use each individual tool, but I'll just give you guys some pointers in, like, the right direction on the tools you can use to make your own packages. So, a tool for making Debian packages is called DebBuild. It's really useful. A lot of people use it. It's just sort of like a standard tool for building Debian packages. And likewise, there's RPM build, which is another like really standard tool for building RPM packages. There's this new tool that just came out recently called FPM. A lot of people really like FPM because it makes the process really, really simple for building packages. So if you're new and you want to like learn about how to make packages, you can check out FPM. It's on GitHub. And two more advanced tools are Mock and pbuilder. And these are tools that the official distributions actually use in some cases to build packages because they create CH roots, sort of like clean room environments for building packages. That way you know for sure that a package has, or that a package has the dependencies that it needs set up properly. Because every time you do a build, the build happens on like a clean base install of the operating system. And so I don't know, previous jobs when I was building packages, package software that we were selling to customers, we did all of our builds through Mock and pbuilder. That way we can ensure that on a clean system, the packages all had the right dependencies that they needed in place, and there was no like weird build artifacts that were polluting future builds. So these are good tools to check out. But there's trade-offs involved with like actually using these tools and trying to make packages, right? Like it takes time to learn new tools. It takes time to understand packaging and like why it's important. And the one thing no one ever has enough of is time, right? Like no one has enough time to like just sit down and learn stuff. But my claim with this talk is just that like, the benefits like far outweigh the cost here, right? Like, once you learn how to make packages, you can build your usable infrastructure much more easily. And you can actually use your production environment for development and test, right? Because you build a bunch of packages, like for the version of Ruby or Redis or whatever that you're using in production. You can go and you can actually install those packages in your development VM, and then you're actually developing and testing and stuff on the same exact binaries that you're running in production. And that makes it like much more easier to build tests for infrastructure, and it just makes like life around debugging and troubleshooting like much simpler. Like the exact binaries you're running in production are the ones you're building, you're testing or developing against. Okay, so like maybe you're sold on, okay, this is really dope, or I'm gonna go make packages for everything. So how do I store and organize my packages? And the answer to that question is with package repositories, as we talked about before. Major distributions keep repositories of packages for their users. If anyone uses CentOS or Fedora or Red Hat or whatever, you've probably heard of EPEL, just a bunch of additional packages that are maintained, I believe, by the Fedora community that provide packages that are sort of outside the normal like base install of Red Hat. There's also the Ubuntu and Debian official repositories where they store all the packages you need to get the system up and running and the dependencies and everything else. And so you can actually build your own package repository on your own system, so you can store your packages and their dependencies yourself, so that you can make it easy to install across the infrastructure. Right, so if you're rolling a version of some custom software that you built and you need a bunch of dependencies, you can put all those in your repository that you have, and then you can install some new machines, and everyone's happy. So how do you create package repositories? Well, I'm going to talk about like the open source tools you can use, and then like how you can use Puppet in conjunction with them to sort of automate the task of actually building repositories up and how you access them securely. So I'm just going to like briefly explain the tools that you can use. So a tool for creating your own repositories is called Create Repo. It's a really popular tool. It's just like it's actually written in Python. A lot of like sort of the RPM and Yum stuff is actually written in Python. So if you're a Python programmer, you can actually read the sources. Don't do that. There's another tool for creating repositories on Debian-based systems called RepRepRo. And RepRepRo is actually like not so great. It's written in C. There's a lot of bugs in it, but it works. So you can use it. If you read the man page for RepRepRo, I strongly suggest do not search for the word corrupt. There's also other free tools available. So if you just like Google and search around, you can find other useful tools for creating package repositories. But you should be sure to read the documentation very carefully. There's lots of tricky options, and we're getting close to the part about the whole GPG insanity, which I'm going to explain a little bit more about when we get there. But I'm going to give you some examples of like how you use these tools to create repositories to get you sort of started. So Create Repo, as I said, is used for generating Yum repositories. And like just a really simple example, right? Like you just make a directory. You can just sort of copy your RPMs in there. You can run Create Repo, and then Create Repo will generate a bunch of metadata describing what RPMs you have, what their dependencies are, and other information about them, like what architecture they're for, build time, size, files, stuff like that. And then you need to run this last step, which is a step that like 99% of people don't actually run, which is you run the GPG step. And what this does is this is going to actually sign the repository metadata. And GPG is really, really important. And using GPG to sign the generated repository guarantees that you, the person who generated the repository, actually did generate it. It's important because that means that no one else modified or removed or inserted a package other than you, right? Like you generated this repository metadata and then you also signed it. And GPG signing the repository metadata is not a very well-known security measure, but it's incredibly important. And the reason why I can tell you that's not a very well-known security measure, aside from the fact that like the company that I work for like does package repositories like as an business, it's also because like the actual option to verify GPG signatures on the repository metadata itself doesn't exist in some early versions of Puppet, like when you're actually using the Yum repo resource type. Like there's no way to tell it to actually verify the repository metadata, which is understandable because like these tools, like documentation for a lot of open source tools around packaging and package repositories is incredibly poor. I just want to point out that signing the metadata of the repository is not the same thing as signing the RPM file itself. Right? So signing the RPM file itself, you use a tool like RPM sign or the RPM binary with the -- sign flag. That's separate, that's a completely separate signature from actually signing the repository metadata. So the proper way to generate a secure YUM repository is to sign the repository metadata with GPG. You can also sign the packages with GPG by using RPM sign. Serve up the repository itself over SSL, and then make sure to enable all the right options for SSL verification, repository metadata GPG checking, package GPG checking, and everything. That's just like a lot of options. You have a question?
So after you install a package with a GPG signature, can you query it and retrieve the image?
Yeah, you can. I forget what flag you used in the past, but in the man page for RPM, you can find there's a flag that will allow you to actually just output the fingerprint of the GPG key that was used to sign it.
What was the question?
Oh, sorry. The question was, once you install the package, is there a way to verify the signature on that package? So I'm actually about to explain how you can use Puppet to install a repository on your system and enable the signature verification automatically. So when you install a package with Puppet, it'll automatically be verified. But you can also verify the signature of the package after it's been installed as well.
Because also you can track, you can use that as a training system.
What do you mean?
If you want to understand if someone installed a package actually from the report.
Right. Yeah. So the question was like, could you use that as a tracking system? And he was just saying that you could, because you could tell based on the signature, the GPG signature on the package, whether or not someone had installed, what repository that package had come from. And that's true. You could like reverse engineer that and upload the fingerprints and figure that out. So just sort of continuing on with like all the crazy options about installing repositories, are like, wouldn't it be cool if you could do all of that with Puppet instead of like worrying about all these crazy options for installing a YUM repository on your system, right? And the good news is that you can, right? So you can actually create a repository via Puppet. And to do that, you can install this Puppet module. And once this module is installed, you can just use the create repo resource type, and you just give your repository a name. You give the repository directory on your machine, and then you can give it a cache directory. And then that will generate the repository metadata for you. There's a bunch of options you can set if you check the documentation for that module that will allow you to specify like how often it should be updated and stuff like that. The one unfortunate thing about this Puppet module is that it doesn't do the repository metadata signing itself. So you need to do that. And the way to do that, like you can do that pretty easily with just using an exec resource. You can actually just use GPG to sign your repository metadata, and then that'll output the signature, and you're good to go. So once the repository is created, it needs to be added to the client machines. I'm not even going to bother explaining how to do that by hand, because you shouldn't be doing it by hand. It's just really, really painful. I'm just going to show how to use Puppet to automate the installation of the repositories on your machines. Puppet comes with a built-in resource type called a YUM repo, and you just can specify like the name, the base URL, and then these two options. Like these are the two options that people always confuse: GPG check and repo GPG check. And like sometimes people will have one but not the other. You really should try to have both if you can. Sometimes it's not in your control, right? If you're using someone else's repository and they didn't set it up right, then you can't. But if you have your own repository, you can set it up properly and you can use both options. Right, so GPG check 1 here means that you're going to verify the GPG signatures on the RPMs themselves. And then repo GPG check sector 1 means you're going to verify the GPG signature of the repository itself. And then GPG key just specifies the URL of the public key. You also want to turn SSL verify on, because in some versions, like some early versions of CentOS and Red Hat Enterprise Linux, SSL verify is actually set to off by default for some reason, I don't know why. So you want to turn that on because verifying SSL certificates is important. And you can also set the SSL CA cert path. So that just gives you the path to all the root certificates. I usually set all these options explicitly myself because I don't know which versions of YUM have bugs in them that will automatically do this for you or not. So I like to be really explicit and just like set these all myself when I'm installing a repository in the system. And so as I said before, most people never turn on repo GPG check or SSL verify or set the certificate path, but you should really think about doing that because these tools have bugs in them. On CentOS 5, they're not enabled by default, so it's a good thing to enable. Question?
What's the cost to the speed of the system?
So the question was, what's the cost of speed of the system? Do you mean like in terms of what? Like in terms of
when you turn on the GPG check, does it just slowdown at all, or is that?
I mean, the verification only happens at install time, so I guess you could argue that the cost of the GPG signature verification is amortized over the life of the installed package. Right? So like, if you install a package like a million times a day, like maybe you'll notice like the cost for the GPG verification. But I don't know. I haven't noticed like any like negative performance implications by enabling verification. And I think that like it's really useful to like know that the packages you're getting are secure. So I don't know. I think it's worth it. I don't like have an exact number or anything. So sorry. Question in the back.
A question from the previous slide, actually. On the previous slide, I think, at least I believe it was the previous.
This one?
No, it was creating repos.
Sorry, say that again.
Creating repos in Puppet.
Yeah. This one?
I'm just wondering. You didn't mention if this also supports Debian as well.
Yeah, there's another. So I'm going to get to the Debian section. There's
Okay.
a separate
Okay.
public
That's fine.
module for Debian. It's completely different than this one.
Okay.
But I'm going to get to that next. Yeah, thanks. Did you have a question? Too?
I got the next slide.
This one?
Sorry. No, the last one we were talking about.
This one? That one?
Yeah.
All right.
Sorry.
No
Can we
worries.
have those resources be pulled down like a base URL and that you can be pulled down from the Puppet Master?
I believe so. I just like this is just like a really basic example that I use for testing. I believe you can. So anyway, you need to use this resource to actually install a repository on your system, but that's not all you need to do. There's like another really important step to actually having all this stuff verified properly. You must install the PYGPG package on the system so that the signatures will actually be verified. So on CentOS 5, like you can enable all GPG signature verification options. You can point at a public key. If you don't have PYGPG installed, Yum will just install the package and not verify the signature, and you'll just have this thing installed without verifying anything, which kind of defeats the purpose. This was actually just a bug in CentOS 5, and they just never fixed it. So if you actually want signatures to be verified, you have to install PYGPG on your systems. And I don't know, like again, like I just like to sort of build things assuming that there's going to be failure. So I explicitly install this package. In newer versions of Yum, this package is listed, PYGPG is listed as a dependency of Yum. So when you install Yum, it's supposed to be installed automatically. I explicitly install it anyway just because I don't actually trust that this bug won't come back again. As I said, without PYGPG, you won't be able to verify signatures. Yeah, I guess too, sorry. Some versions of CentOS and Red Hat don't automatically install that with Yum. So you can just run this. You have this in your manifest. You just install PYGPG, the latest version, you're good to go. Okay, so now I'm going to just talk about RepRepRo and how to create app repositories via Puppet as well. So I'll first go through like an example of how you use RepRepRo like on the command line, and I'll show like a Puppet module you can use instead. So first, you just begin similar to query repo, right? You create a directory for your stuff to go. You create a conf directory underneath that, and then you create a file called distributions inside the conf directory. And that file will have some fields like this, like you'll have the code name, which will relate back to the actual code name of the Ubuntu or Debian version that these packages in this repository relate to. So in this case, I have code names set to precise, which maps to Ubuntu 10.04, the LTS version. You can set a component. In this case, components, I just have components set to main, but there's other components as well, like non-free, constrained, whatever. You can sort of like pick your own if you want. And then you list the architectures of the packages that are going to be in this repository. I just have the two that I use, i386 and AMD64. And then there's a sign with field. And the sign with field here, this is the GPG key ID of the GPG key to use to sign the repository metadata that's generated when you run RepRepRo. You can add more sections if you need more code names. Like if you need support for Precise and Lucid and Trusty and whatever, you can just add additional stanzas to your config. And as I was just saying, sign with specifies GPG key to use for assigning repository metadata. And you can get your GPG key ID by looking at the output of GPG --list keys. The IDs are listed to the left of the keys. And setting the sign with field in the distributions file is not the same as using devsigs or devsign. Devsigs and devsign sign the Debian file. Sign with in the distributions file sign the metadata. The unfortunate thing about the way that Ubuntu and Debian work though is that if you use devsigs or devsign to sign your Debian file, That signature is not going to be verified by default. It's all signature verification on the actual Debian packages is disabled. There's a few reasons why this is the case. One of them is because of the way that DebSigs actually works. So to verify GPG signatures on Debian packages that are made with DebSigs, you need to create a really crazy looking XML policy file to describe like what key should be used to verify packages and a whole bunch of other stuff about it. It's just really, really painful, and so no one uses it, and the official Debian packages and Ubuntu and Debian don't even use it either, which is why it's just disabled by default on Ubuntu and Debian machines. So you really want to sign your repository metadata, so like using signs with in the distributions file is really, really critical for Ubuntu and Debian repositories because there's no GPG signatures on the packages themselves. So you can import your Ubuntu 12.04 packages by just running this really long command line, just running repreprow, giving it the base directory of the repository, include dev, the distribution, and the file name. It's painful, and so it wouldn't be really dope if you do that with Puppet instead. And the good news is that you can do that with Puppet instead. You can create app repositories by using this Puppet module, and I'll show you sort of like what that looks like when you're actually using it in practice. So you can just set a base, this is just straight from the documentation of that module. You can just set a base directory, create sort of the repreprow class that has the base directory set up, and then you can just use the this repository resource to just actually create the repository itself. You point at the base directory, and then you set up a separate distributions resource. This maps back to that distributions file that I was just talking about. You use this distributions resource to set up all the information about what architectures you're going to use. In this case, like in the example, AMD64 and i386. What components you want the distribution to support, main, trig, whatever, and then which GPG key to use to sign the metadata. That's what you set signs with. And then once the repository is created, it has to actually be added to the client machines. And so you can do that with Puppet as well. You can install a Puppet module called Puppet Labs module apps, and you can use the app. You can use this resource called app source. You can set the name of the repository, the location, which release you're using. So if you're using a precise machine, you set precise, and that'll grab the packages that were uploaded to the precise distribution in that repository. You can set which component you want. So in this case, main again. The GPG key ID, and then the URL for the GPG key that should be used to verify the signatures. But that's not all, right? Like, you must also have the apt transport HTTPS package installed in your system if the repository is served over HTTPS. If you don't have this installed, package installed, and you try to install a package from a repository served over HTTPS, apt is just going to fail with a really cryptic error message. So you really want to install apt transport HTTPS because you probably want to install your packages over HTTPS. It's a good idea to do that. And so you can install an apt package. You can install apt transport HTTPS like this by just using this package resource. And that's it, right? Like here we go. Like, we've made these package repositories, we made packages, we set up all the GPG stuff, right? Like we succeeded, right? But the question is to what end, or like why did we do all this? Well, one reason that we did all this is because you can now use like Beaker, Kitchen CI, or whatever to test your infrastructure. You can determine if the packages you need are actually installed after your manifests are applied. You can determine if the repositories you added are actually added after your manifests are applied as well. And you don't need to wait forever for Ruby or Redis or whatever to be compiled during a test run of Kitchen CI or Beaker. You can just test the things that need to be tested, and all the build stuff happens externally to that. But the best part of all, and my favorite part about going through this whole React shave, is that now you can run Puppet on your development VM and use the same manifest used in production to install the same package you use in production, so you can develop against a system that's a lot more similar to production than maybe you were using before that, right? The manifest applied, you're running the same exact binaries you're running in production, and that'll help you. That'll help you catch some bugs. Obviously, that's not 100% foolproof. You won't catch 100% of production bugs by doing that, but it brings you, it closes the gap a little bit between what you're running on your laptop and what's running on your actual, production environment. So I don't know. That's why I think it's pretty dope. So the summary of just the packaging stuff is that Creating package repositories can be tricky. Make sure to GPG sign repository metadata. 99% of package repositories out in the wild get the GPG sign with the metadata incorrect. So make sure to carefully read the documentation of CurryRepo and RepRepRep. And make sure to install all necessary libraries for verifying signatures and accessing repositories over HTTPS. You're going to need, like we said, you're going to need PyGPG on RPM-based systems, or you're going to need apt transport HTTPS on Debian-based systems. And if you can, always screw up your repositories over HTTPS. And most of all, you should use Puppet to automate this if you can. And so that's it. If you have any questions about packaging in general or repositories or whatever, this is the my company's Twitter handle. You can just mention us on Twitter, and I'm happy to help answer any questions. My email address is on here too. I'm just joe@packagecloud.io. So if you have any questions about repositories or GPG signing or whatever, just send me an email. And I don't know if I have time for questions, but so.
You can take a few questions.
All right, and if anyone has any questions, I'll take those now. But thanks a lot for coming and listening to me talk about packaging.